Hello everybody. Come let's go with methods of voltage control. In this method of voltage control, inductive reactor absorb reactive power and may be used in circuits. That circuits connected in series or shunt. While series connector reactor are used in limited fault current, shunt reactor are used for VAR control. If reactors installed at line ends and intermediate substation can compensate up to 70% of charging power, while the remaining 30% of power at no load can be provided by the under excited operation of the generator. With increase in load, generator excitation may be increased with reactors gradually cut out. It contains many categories. That categories are listed below: shunt capacitor, series capacitor, synchronous capacitor, SPC, tap changing transformers, booster transformer. Let us see the shunt capacitor. Capacitors produce VAR and may be connected in series or shunt in the system. Series capacitor compensate the line reactance in long overhead line and thus improve the stability limit. However, they give rise to additional problem like high voltage junction, subsynchronous resonance, etc. Shunt capacitors are used for reactive compensation. Simplicity and low cost are the chief consideration for using shunt capacitor. Further, for expanding system, additions can be made if the shunt capacitor through the tertiary of a transformer connection is a most important connection in shunt capacitor. Come, let's go with a series capacitor of second classification. Here the capacitors are connected in series with the line. The main aim is to reduce the inductive reactance between supply point and the load. The major disadvantages of the method is whenever short circuit current flows through the capacitor, protective devices like spark gap and nonlinear resistors are to be incorporated. Next, phasor diagram for a line with a series capacitor always being with a combined of inductance and capacitance. This relative merits between shunt and series capacitors, or if the load VR requirement is small, series capacitors are of little help. Then if the voltage drop is the limiting factor, series capacitor are effective. Also, to some extent, the voltage fluctuation can be even. If the total line reactance is high, series capacitor are very effective and stability is improved. With series capacitor, the reduction in line current is small. Hence, if the thermal consideration limits the current, little advantage is from this. So, shunt compensation is to be used. Third one is series capacitor, shunt capacitor combination, and the sense of called synchronous capacitor. A synchronous compensator is a synchronous motor running without a mechanical load and depending on the excitation level. That means it can be either absorb or generate reactive power. When used with a voltage regulator, the compensator can automatically run over excited at times of high loads and under excited at light load. A typical connection of a compensator along with associated voltage VR output characteristics. A great advantages of the method is the flexible operation for all load condition. Then in the sense of being a rotating machine, its stored energy is useful for riding through transient disturbance including voltage drop. Even though the capacitor and reactor is connected to the low voltage side of a down transformer, the capacitor bank may be distributed between high and low voltage buses. The capacitor bank often includes in part harmonic filter which prevent the harmonic current from flowing in the transformer and the high voltage system. Filters for the fifth and seventh harmonics are generally provided. The thyristor controlled reactor, that is a TCR, is operated on the low voltage bus in another form of the compensator. The reactor compensator is connected to the secondary of a transformer. With this transformer, the reactive power can be adjusted to anywhere between 10% to the rated value, with a capacitor bank provided with steps of full control range from capacitive to inductive power can be obtained. The reactor's transformer is directly connected to the line so that no circuit breaker is needed. Next one is static VR compensator, that means SPC. In recent years, reactive compensation of charging power is made feasible with the application of three-phase thyristor and power control circuit with automatic control function. The term static VR compensator is applied to a number of static VR compensation devices for use in shunt reactive control. These devices consist of shunt connected static reactive element, that mean a line or non-linear reactor and capacitor configured into a VR compensating system. Some possible configuration are shown in the mentioned figure in the next slide. Even though the capacitor and reactor are connected to the low voltage side of a transformer, as I mentioned earlier slide, the capacitor banks may be distributed between high and low voltage buses. The capacitor bank often includes in part harmonic filters which prevent the harmonic current from flowing in the transformer and the high voltage system. Filters for the fifth and seventh harmonics are generally provided. The thyristor controlled reactor TCR is operated on the low voltage bus in another form of the compensator. The reactor compensator is connected to the secondary of a transformer. Then the primary winding is star connected with the neutral grounded, suitable to the thyristor network. The secondary reactor is normally non-existent as it is more economical to design the reactor transformer with 200% leakage impedance between primary and secondary winding. The delta connected tertiary winding will effectively compensate the triple harmonics. The capacitor bank is normally subdivided and connected to the substation busbar via one circuit breaker per subbank. The regulator generates firing pulses for the thyristor network in such a way that the reactive power required to meet the control objective at the primary side of a compensator is obtained. The reactor transformer has practically linear characteristics from no load to full load condition, thus even under all strain over voltages. Hardly any harmonic content is generated due to saturation. The transformer core has non-ferromagnetic gap to the required linearity. Some of the following objectives has been maintained the following compensator. That compensator or a reaction should be possible, fast or slow, whenever demanded. No switching of capacitor should take place at that time to avoid additional transient in the system. Commutation from capacitor to reactor and vice versa should be fast. No switching of the capacitor at the high voltage bus bar, then that no higher frequency transient is produced at EHV level. Elimination of higher harmonics on the secondary side and blocking them from entering the system. In a three-phase system, the thyristor control inductor are normally delta connected as to compensate unbalanced load, and the capacitor may be star or delta connected. In the thyristor control reactor, the inductive reactance is controlled by the thyristor for limited range of operation, and the relationship between the inductive current and applied voltage is represented. As the inductance is varied, the suspectance varies over a range within the limits B suffix of L minimum and B suffix of L maximum corresponding to XL maximum and XL minimum, while the voltage changes by V volts. The current flowing in the inductance would be different in each half of cycle, varying with the conduction angle such that each successive half cycle is a smaller segment of a sine wave. Then the fundamental component of inductor current is then reduced to each case. Then the fundamental component has adjusted by giving a proper step input to the firing angle control static VR compensator when installed reduce the voltage swinging at the rolling mill, and the system buses in drive